Number 4. Whoa! What do we do with this guy? Well, what we want to do is we always want to get everything set equal to 0. Now, you could move the 4n squared over, but I don't want to deal with a negative. So let's always try to avoid that if we can. So I'm going to move the 2n squared over by adding 2n squared. So over here, we'll add 2n squared. That'll balance it out. Let's move the 13 over. How to get rid of adding 13? We're going to subtract 13n. And then to get the negative 4 over, we're going to add 4. So just here on the end, we're going to add 4. Let's see what we get. We know on the right-hand side of the equal sign, we have a 0 because everybody went away. They moved to the left side. 4n squared plus 2n squared is 6n squared. Gain 2n, lose 13n. That's losing 11n. And then you have the plus 4. So we now have the trinomial set equal to 0. We now must factor this because this section's about factoring. We learned last section how to factor when this number in front is not just a 1, when it's 2, 3, 4, whatever. This is your A value, this is the B value, and this is your C value. And what we're going to do, if you remember, we're going to bust B apart. So how do we do this? Well, if you remember, we multiply the A and C value, which gives us 24. We think of the factors of 24. Now, it is a positive 24. Okay, great. That means either both pieces are positive or both are negative. I know they're both negative because right here it has a minus 11n, but we'll deal with that in a minute. 1 times 24 is a possibility. Now 2 times 12, 3 times 8, 4 times 6. They're both negative, as we said, because it's going to be a minus 11n, so they're both negative because negative times negative gives you the positive 24, but added is going to give you a negative. We want a negative 11. I can easily see it's a minus 3 and a minus 8. So I'm going to put 6n squared. I'm going to put a minus 3 in here, and it's going to be a minus 8n. So we busted the b into a negative 3n and a negative 8n. Okay, and now we need to factor this. So it's in 4 pieces, so we're going to factor by grouping. Now, I'm going to group these. I would group these, but I have that minus right there, and I can't do that. Okay, it's a little tricky. A lot of extras here that we've got to pay attention to. So I simply change this to plus a negative 8n and then can group. So as long as I have a plus between the two pieces I'm grouping, I'm good. So I need to factor out of this first grouping, 6 and 3. Well, 3 can come out, n squared and n can come out. 3 times 2 is 6n, n times n is n squared. 3n times a negative 1 will be the minus 3n there. So, because both the 3 and the n factored out and left behind the 1. Plus now, here as I said, when we bust b, you've got to factor out the negative piece. 8 and 4, a negative 4 is what we're going to factor out. We'll be left behind with negative 4 times 2 gives me that negative 8n and that 2n. And then negative 4 times what gives you that plus 4? It's going to be a negative 1. Negative 4 times negative 1 gives you that plus that you need. So now what do we have? Well, let's scroll down a little bit. Notice that we have the 2n minus 1 and the 2n minus 1. It's all set equals 0. We're going to factor the 2n minus 1 out front, and we're left behind with 3n plus a negative 4, which we will simply write as a minus 4. Added loss of 4 is the same as minus 4. We'll switch it back to a minus 4 there. Equaling 0. So we have two binomials multiplied together equals 0. One of these two has to be a 0. If two numbers multiply give you 0, one of them's got to be a 0. So I set this guy equal to 0 and solve it. I'm going to set this guy equal to 0 and solve it. So now add 1, 2n equals 1, divide by 2. What do you have? A half. There's one solution. Add 4, 3n equals a positive 4, divide by 3, 1 and 1/3 or 1.3 repeating. So those are your two solutions. Now, technically what that means is those are where it's crossing the x-axis. So it's crossing here at a half, 0.5, and 1 and 1/3 right there. And so it's sort of a little skinny parabola coming down in through there, crossing them. But again, what we want is a half and 1 1/3. If you plug those into the original equation back up here, plug it into that ends, the two sides are going to be equal.